So Mr. CB, Haber's process. Now Haber's process is used for the manufacture of Mr. CB for the
Ammonia.
manufacture of ammonia, NH3. Now the interesting theory is this is called Haber's process because the process was made by Mr. Haber. Do you know some interesting fact about Mr. Haber, Mr. CB?
So Haber was, you could say, a German official, and his discovery was instrumental in World War I because it provided Germany with like source of explosives to detonate on the French line.
Yeah. So now Haber process is mainly used to produce fertilizer today, but during World War I, Germany used this as a source of with a source of ammonia for the production of explosives. They used ammonia for the production of explosives. So, for example, at that time also they teach you in history that, for example, now they have these trade blocks against Russia. Now at that time they were having all these trade blocks against Germany. So that is why this process got invented by Mr. Franz Haber, and indirectly the process is the production of ammonia is responsible for the population explosion that we are facing today. Can you see this line?
Yes, sir.
So this is some interesting trivia. So the Haber process served as a detonator of the population explosion, enabling the global population to increase from 1.6 billion in 1900 to 7.7 billion by November 2018. Now you might be wondering how Haber process became a population explosion. See, the problem was, the problem or opportunity, whatever you call it, is that ammonia is heavily used in the manufacture of fertilizers. Mr. CB, any doubt?
No, not.
Now if whenever you have time, you can go through this. So the yield of the crop remains, the yield of the crop increases substantially when fertilizer is added to it. Have you understood?
Yes, sir.
Now ammonia is used for making fertilizers. Now have you understood how ammonia helped in the increasing the population?
Yes, sir.
So now after this trivia, let us start making sense of what we are saying. Now this seems to be a complicated process, but simply this is what will be happening. You will be taking nitrogen and hydrogen. Can you see nitrogen and hydrogen?
Yes, sir.
So nitrogen and hydrogen will be taken. Both will be compressed to a very high temperature of more than 200 degree atmosphere. So this mixture, the equation of the process is very simple, that you would have done in your lower classes also. So the equation is pretty simple. It is just N2 plus 3H2 gives NH3 plus heat. It's an exothermic reaction. So the reaction is pretty simple. The process seems a bit complicated. So this is the reaction which will be taking place. This will be the reaction which will be taking place. The reaction will be taking place in this catalyst chamber. We will be providing electrical heating. In the presence of catalyst, the reaction will be taking place. So N2 plus H2 gives NH3. You can balance the equation. Now whole of the ammonia, whole of the nitrogen and hydrogen doesn't get converted into ammonia. So you will take out, if you see this like, you will take out the nitrogen, hydrogen and ammonia. You will take this to the condenser. From condenser, the temperature will come down. When it comes down, ammonia as a liquid will be separated out. But the remaining nitrogen and hydrogen, which couldn't get converted into ammonia, it is compressed and it is resent to this catalyst chamber again for manufacture. Is it making some sense or not?
Yes, sir.
Okay. Now let us see this and let us again try to understand. So I have taken nitrogen and hydrogen. These are dry. These are in the ratio of 1:3. I have compressed them to a pressure of 200, more than 200 atmosphere. Is it making sense?
Yes, sir.
Now I take this to this chamber. This is my catalyst chamber. Now what will be happening in this chamber? Let us look closely. Just focus on this chamber. See, the temperature would be, it is already an exothermic reaction. The temperatures would be maintained at around between 450 to 500 degrees Celsius. So this ammonia, this is a nitrogen and hydrogen which you have compressed. This will be nitrogen and hydrogen which will be compressed. Now this nitrogen and hydrogen is coming down. Then it goes through this catalyst. We will discuss the catalyst and the promoter in detail in the next slides. But for the time being, you can just say that this is the bed of catalyst through which the mixture of nitrogen and hydrogen is passed. There is a heating coil. So this is a catalytic heating is taking place in this chamber. These are heat exchangers, and then if you see that N2H2 and NH3, because see, this might be confusing at first because all the hydrogen and all the nitrogen won't get converted into ammonia. You will have part of nitrogen and hydrogen which won't get converted. Mr. CB, is it making sense or not?
Yes, sir.
So these three are taken to this condenser. Now the temperature would be dropped. Do you see this hot water going from cold water going from this end and hot water coming from this end? So basically in this chamber what will be happening is that this mixture would be liquefied. Now I will show you the the boiling points of all these three gases, and you will understand when you look at the exact boiling points that ammonia will liquefy first. Is it making sense?
Yes.
So ammonia will liquefy first, nitrogen and hydrogen won't liquefy. So here the sudden expansion of ammonia would happen. Ammonia will get converted into liquid state and ammonia will separate here and it will be taken out. The remaining N2 and H2, because N2 and H2 won't get liquefied, this nitrogen and hydrogen is again compressed and sent back again to this catalyst chamber. Mr. CB, is it making sense?
Yes, sir.
So broadly, I think you would have understood that the reaction is very simple. You take nitrogen and hydrogen, they react in the catalyst chamber. The catalyst chamber is electrically heated. The N2, H2, NH3. So this N2 and H2, again and again I am saying that N2, H2 are the unreacted N2 and H2. So N2, I think I'll mention here to avoid the confusion. So this is unreacted. This is unreacted N2 and H2 plus NH3 goes to the condenser. In condenser, ammonia will liquefy first and it will separate. The remaining N2 and H2 will again be compressed and sent to the catalyst chamber again. Is it making sense?
Yes.
I just wanted to add 2-3 more things. I hope you won't be getting confused. See, one thing that you just remember, because it will help you in the next lectures also, is this ammonia that you will be manufacturing here. This ammonia would be used in the making of nitric acid in Ostwald process, which is next part of this chapter. So CB, is it making sense or not?
Yes, sir.
Okay. Now there are few other, one or two other things that I wanted to share. I won't be going into the details, but the hydrogen and nitrogen, the nitrogen is made from fractional distillation of air. This seems to be complicated, but all it is trying to say is that the nitrogen, all that we need to remember is that nitrogen we get from air with fractional distillation. If you get into engineering, if you are interested in engineering, then you will be understanding what is fractional distillation of air, but right now it is not required. We understand all that we require. All we understand is that air, how much percent is nitrogen and how much percent is oxygen, Mr. CB?
Sir, 21% is oxygen, 78% is nitrogen, and the other 1% constitutes other gases such as carbon dioxide, helium, etc.
So this nitrogen which is available, this nitrogen that we get, that we use in this process, simply what you can understand is that this nitrogen that you would be using in this process you get from air. The second thing is about hydrogen. The hydrogen which is being used here, it is obtained from natural gas. It can also be obtained from Bosch process. Bosch process, if you remember, you would have done it in class 9th. Again, I won't be going into the details, but nowadays most of the hydrogen gets you get it from natural gas. Mr. CB, any doubt till here?
No doubt.
Actually, if you are interested, on the same wiki page, I'll show you the full process. So, for example, this is the whole process which is used. The process which is mentioned in our book starts from here. Can you see this process?
Yes, sir.
Now, this process, I will change the color. This process is actually the production of nitrogen and hydrogen. Is it making sense or not?
Yes, sir.
This is the production of N2 and H2. This is the production of ammonia. Is it making sense?
Yes, sir.
Now, just see here. You are giving methane, water, and air. So, natural gas and air, that is being used for manufacturing nitrogen and hydrogen. That nitrogen and hydrogen, once this nitrogen and you have got the nitrogen and hydrogen, then the production of ammonia starts. Do you see this?
Yes, sir.
And another interesting thing that you need to see is, if you see the last process, this cooler, the ammonia that you get from this process is in liquefied form. Is it making sense?
Yes, sir.
Okay. And so if you are interested, you will get all the links here. Plus, if you are more interested, so for example, this link will tell you about the production of nitrogen from liquid air. This is called fractional distillation. I don't want it to go into detail, but if you are interested, you can have a look at this link and understand. This is how you get hydrogen from methane. Is it making sense? So most hydrogen produced today in the United States is made via steam, methane reforming, mature, high temperature steam, etc., from a methane source such as natural gas. So natural gas is the provider of the methane, which is used to make hydrogen. Mr. Sivang, is it making sense?
Yes, sir.
So nitrogen, hydrogen, they are not, the production of nitrogen, hydrogen is not in your syllabus. I just wanted to give you a reference. Some other fun trivia. India exports around 6 million ammonia. And so this is the amount, this is the dollar amount that India exports. And this is the dollar amount that India imports. Can you see the figures?
Yes, sir.
I'll zoom it so that you can see better. So if you see 5.7 million is exported and 1.4 billion is imported. Can you see the figures?
Yes, sir.
And the ammonia which is imported, we get it from Saudi, Qatar, Ukraine. Can you see Ukraine and Russia?
Yes, sir.
And nowadays, as you can imagine, this import will get affected which will affect the fertilizers, because ammonia would be used in the manufacture of fertilizer. Is it making sense or not?
Yes.
And if you see another thing that if you are able to connect the dots is that Saudi and Qatar, because they are very Ukraine, Russia, they are very rich in natural gas. So the natural gas is being used for manufacture of hydrogen, which gets converted into ammonia, and which is exported, or fertilizer plants is used in fertilizer plants. Of course, this is trivia. This is not part of your syllabus. So let us rush back to the syllabus. Mr. CB, are we clear till here?
Yes, sir.
Now, before we go ahead, we'll have to spend some time. I think this is clear now. We'll have to spend some time to understand what is the LECHATLIER principle. Now, simply what LECHATLIER principle says is that if you increase temperature, or if you increase pressure, or you increase concentration, or you increase volume, the equilibrium of a reaction will shift in a direction so that the system can relieve the stress. Is it making sense or not?
Yes.
It is not making any sense. Okay, let me explain it to you with an example. Of course, let us actually, I think what we'll do is we'll take this example of ammonia first. Okay, and then I'll show you with another example. We'll take two examples because we are doing ammonia, so let us first understand this. Okay, now you have nitrogen, you have hydrogen, you have ammonia, this is an exothermic reaction. This is an exothermic reaction in the forward direction. Is it making sense?
Yes, sir.
So in the forward direction, this is exothermic, and if it takes the backward direction, it will be endothermic. It will be using this heat. So CB, is it making sense?
Yes, sir.
Okay. Now let us increase the temperature. Let us see the effect of increasing the temperature. Now, if I increase the temperature of the system, the system will try to relieve the stress of the increase of temperature. How it will try to relieve the stress? It will try to decrease the temperature. Is it making sense?
Yes, sir.
The reaction on its own will try to decrease the temperature which you have increased. Is it making sense or not?
Yes.
Now it can only decrease the temperature if it goes in the backward direction. Is it making sense?
Yes, sir.
Because if you increase the temperature, if you are increasing the temperature, the reaction will try to decrease the temperature. Now the reaction can decrease the temperature only if it goes in the backward direction. Is it making sense?
Yes, sir.
Because the backward direction is endothermic. It will be using heat. Is it making sense?
Yes, sir.
So what you want is more amount of ammonia. So that is why what you want is you want to decrease the temperature. So that the system increases the temperature. Is it making sense?
Yes, sir.
And how will the system increase the temperature? By going in the forward direction, because the reaction knows that if it goes in the forward direction, then a lot of heat would be produced, which will increase the temperature. Is it making sense?
Yes, sir.
So basically, what I'm trying to tell you is, I'll take the example of sulfur also, that SO2 also, because that is also important. That will be used in the sulfuric acid contact process. So basically, the system. When I say a system, I'm talking about the equilibrium reaction. Basically, the system behaves like a teenager. So if you tell him to go out and play, he will say, or he or she will say, no, I want to study. But if you tell the teenager to study, then it will say, no, I want to play. Mr. CB, is it making sense or not?
Yes.
So in this reaction, N2 plus H2 NH3, this is the equilibrium reaction. So this is 2, this is 3. Is it balanced now? Yeah. So this is an exothermic reaction in the forward direction. It is exothermic. Now if I increase the temperature, high, then the system will want to decrease the temperature. It can only decrease the temperature if it goes in the backward side. Mr. CB, is it making sense?
Yes, sir.
So the better option for me, is if I see a reaction like this, and I want more and more amount of ammonia, because it is ammonia that I'm interested in, and I know that it is an exothermic reaction in the forward direction, then what I should do, Mr. CB?
So then it would be preferable if you decrease the temperature.
I decrease the temperature. Why I decrease the temperature? Because once I decrease the temperature, the system would want to go in the forward direction. Why? Because when I have decreased the temperature, system wants to increase the temperature. Now because system wants to increase the temperature, it will have to go in the forward direction so that lot of heat is produced. Mr. CB, is it making sense?
Yes, sir.
So if we want more and more amount of ammonia, then we should actually be, doing this reaction at a lower temperature. Is it making sense?
Yes, sir.
But then what is the harm of decreasing the temperature too much?
So the reaction is slow and the yield of ammonia is also low.
If you lower the temperature, lower the temperature too much, then the rate of reaction will go down drastically. Is it making sense?
Yes, sir.
So that is why you will see this word again and again in these chapters. Optimum temperature. Optimum temperature. Have you understood now?
Yes, sir.
Now let us look at another factor which will affect the production of ammonia and the effect of LECHATLIER. Now if you see on this side you have 4 moles. Is it okay?
Yes, sir.
This side you have 2 moles. Is it okay?
Yes, sir.
Now let me take another factor. Let me take pressure and increase it. I have increased pressure. I have increased pressure. What will system try to do?
It will try to decrease it.
It will try to decrease it. It will try to decrease it. How can it decrease it? Let's analyze. I have 4 moles here. I have 2 moles here. If you go in the forward direction, does the pressure decrease or increase?
So pressure will decrease.
Pressure will decrease. Pressure decreases. See, try to understand. Na? You have this vessel in which you put 1 plus 3 moles of, let us assume we take 1 mole of nitrogen and 3 moles of hydrogen. Then 2 moles of NH3 is formed. Everything is in vapor state, gaseous state. Now, common sense will tell you when 4 mole of gases get converted into 2 mole of a gas, of course the pressure would be relieved. Is it making sense?
Yes, sir.
So if you increase the temperature of the system will try to relieve the increase in pressure by going in the forward direction so that the pressure is decreased. Mr. Sibang, is it making sense or not?
Yes.
So what kind of pressure conditions will we prefer?
The pressure would be lower.
So if we take higher pressures, system will try to, if we take higher pressures, system will try to decrease the pressure. We know in the forward direction, the pressure is decreasing. So more and more pressure is increased. Will the production of ammonia increase or decrease?
Because more pressure favors the forward reaction, then yield of ammonia will also grow.
See, more pressure you increase, the system will try to decrease the pressure by going in the forward direction. And that is exactly what you want. Is it making sense or not?
Yes.
You want the system to go in the forward direction. So it will be better for you to increase the pressure as much as possible. Is it making sense?
Yes, sir.
But should you increase the pressure as much as possible?
No, sir. Then the plant cannot bear the pressure.
See, what Mr. LECHATLIER is saying is that it is preferable that you increase the pressure. But you understand that if you increase the pressure, what will happen is, 1, the cost will increase because you'll have to spend energy to increase the pressure. Is it making sense?
Yes, sir.
The second thing is in the vessel in which the reaction is taking place and 2 plus H2 forms NH3. So in this vessel, the wall of the vessel will have to be made very strong. Why, Mr. CB?
So because so that it can withstand high.
So that it can withstand the pressure. But then as you start making the walls thicker and thicker, again the cost will increase. Is it making sense?
Yes, sir.
So again you will have to find an optimum pressure which is high enough but not very high enough. Is it making sense?
Yes, sir.
And the third reason is that the whole of the factory becomes very dangerous. Why does it become dangerous?
So because it can explode anytime.
Yes. If the vessel explodes due to any reason, what will happen is, because you have increased the pressure so much, it will cause lot of damages. Is it making sense?
Yes, sir.
Now the same thing we will be, of course, when we do sulfuric acid, again we will be discussing this factor. I will just introduce the same thing will be happening in the production of sulfuric acid in contact process also. So if you see this side, 3 moles are used and 2. So if the pressure is increased, the system will try to relieve the pressure by going in the forward direction. And of course that is what you want. Is it making sense or not?
Yes, sir.
So high pressure is preferred. But the optimum temperature which is used is 2 atmosphere. Yes or no, sir?
Yes, sir.
Again, because it's an exothermic reaction, then again if you make temperature lower, system will try to increase the temperature because it knows that if it goes in the forward direction, thus temperature will get raised. But the problem is that too much low temperature will decrease the rate of reaction. So that is why this figure in contact process is the optimum temperature at which the reaction happens. Yes or no, sir?
Yes, sir.
Okay. Another thing that we will be studying in when we do contact processes, higher concentration of oxygen is preferred, because more the oxygen that you use, what the system will try to do is it will try to decrease the concentration of oxygen. How can it decrease the concentration of oxygen? It can only decrease the concentration of oxygen by going in the forward direction, by using more and more and more of oxygen. Mr. Sibang, have you got a fair amount of idea about the LECHATLIER principle or not?
Yes, sir.
So in which two processes will LECHATLIER principle be important?
So in
Yeah.
Haber's process and sulfuric
In the contact, in the contact process. In these, both of these, the LECHATLIER principle would be very important. So question will also be asked about LECHATLIER principle. This is a very important topic. So the temperatures are that are optimum temperature and optimum pressure. The pressure is more than 200 atmosphere. The temperature is 450 to 500 degrees Celsius. Now these are, again, you'll have to remember this. The catalyst is finely divided iron, and at times they ask this question also, why is it finely divided?
So that there is no surface absorption.
Mr. Sibang, you want more and more surface to be exposed.
Yes.
The surface should be exposed. Sir, you haven't understood well. Let us assume you put a block of iron. You put a block of iron. Will it behave like a good catalyst?
No, sir.
Why, sir?
So because there is not enough surface.
Because there is no surface area. So what you need to do is you need to grind this so that it gets converted into very fine iron particles, so that the effect of the catalyst
is greatly increased.
Is increased. भाई समझ में आ रहा है या नींद आ रही है?
समझ आ
इसका जो surface area है, and if you powder it, the surface area of this powder is increased substantially. So do you understand this or not?
Yes, sir.
So whenever you grind any substance, so for example, let us take a very simple example. So you have this cuboid. Now you break this cuboid into smaller pieces. The surface area, the total surface area of the smaller pieces would be
the greater
than the
big block of iron.
Big block. That is why this question is asked in an exam. That why do you prefer finely divided iron? Mr. Sibang, is it making sense or not?
Yes, sir.
Then there is a promoter which is used. The promoter which is used is molybdenum. The promoter basically activates the catalyst, increases the effect of catalyst. Is it making sense?
Yes, sir.
So, it's like you should eat fruits, but there are people who eat fruit, but then they take some vitamin also, just as a supplement. They are called supplements. So this is how the catalyst and the promoter work. So these are important questions. The reasons that we have discussed for LECHATLIER, this is an important topic. Again, this finely divided iron, why is it preferred? Again, that is also a very important topic. Mr. Sibang, have you understood this or not?
Yes, sir.
Okay. Now there are a few other things that you need to understand. One is the nitrogen and hydrogen which is used should be pure. Otherwise, it will poison the catalyst. What is the meaning of poisoning a catalyst?
Poisoning the catalyst in the sense that it doesn't allow the catalyst to do its job.
It doesn't allow the catalyst to do its job well. Basically, there will be products will be found which will cover the catalyst. They will cover the surface of the catalyst. Now, the surface of the catalyst is very important for the catalyst to work well. Is it making sense?
Yes, sir.
So that is why nothing should cover the surface of the catalyst. And if you do not take nitrogen and hydrogen, if you don't purify it well, you don't dry it well, then you'll have these substances, extraneous substances which you don't require will be found, which will cover the surface of the catalyst that you are using. Are we clear till here?
Yes, sir.
Now, another thing that I wanted to share with you is that we discussed in the beginning of the lecture was about the liquefaction. Do you remember?
Yes.
See, I'll remind you because we have gone through a lot of concepts. So, for example, here, if you saw a mixture of nitrogen, hydrogen, ammonia, and I told you that this will be here, condenser would be there, which will use basically the latent heat of water to decrease the temperature of the mixture. And here, due to rapid cooling, due to rapid expansion, you will understand this sudden expansion. See, what you need to understand is that maybe in physics, you will of course understand this in detail when you do thermodynamics in class 11th and 12th. But one question that you might have done in physics is that when a tire tube bursts, it cools down. That cooling effect is due to the rapid expansion of air. So all you can understand now is, or cram now is, that due to rapid expansion, air cools down, or a gas cools down. Basically, if you have if you have a gas that you have put under immense amount of pressure in a vessel and you suddenly open the vessel, you let the gas go out, it will cool down. Is it making sense, Mr. Sigma?
Yes, sir.
You will understand that this is part of adiabatic cooling in class 11th, 12th. So here, this ammonia which is formed, it expands suddenly, and that is why it cools down. The vapor cool down, and that is why you will have this liquefied ammonia. Do you understand now?
Yes, sir.
And the nitrogen and hydrogen do not cool down, so they still remain in the gaseous state, and that is why the uncombined nitrogen and hydrogen is being taken out. Can you see this compressor? And this uncombined nitrogen and hydrogen is taken again to the catalyst chamber for manufacture of ammonia again. Now just look at these temperatures, and maybe you will understand what I'm trying to tell you. If you look at these temperatures, now ammonia, it will get liquefied at minus 33 degrees Celsius, but you have to take nitrogen to minus 196 degrees Celsius to liquefy, and hydrogen you have to take to minus 253 degrees Celsius. Mr. CB, have you understood?
Yes, sir.
What is the absolute value of
minus 273?
Minus 273. Minus 273 is the lowest possible. So you can imagine how difficult it is to liquefy hydrogen. Is it making sense?
Yes, sir.
So very low temperatures hydrogen is, and nitrogen is still better because it is at around minus 196. But just look at the figure. At minus 33 degrees Celsius only, you will have ammonia will liquefy. What is the coldest place on Earth, Mr. Siva?
Antarctica?
I don't know. I think it might be somewhere in Siberia. Let us look. So this is what we have found in Russia. The temperatures are minus 50 degrees Celsius. Mr. CB, can you see this?
Yes, sir.
Basically what this implies is that you will have ammonia in liquid state at that place.
Yes.
Because the temperature is around minus 50. I think it was minus 50.
Minus
Ammonia
50.
will liquefy at minus 33 degrees Celsius. So if there is any ammonia, it will get liquefied. Mr. CB, are the things making sense or not?
Yes, sir.
So basically this is the industrial manufacture of ammonia. This figure is not important as per your exam point of view. The things which are important are, which I feel important are, one would be a good understanding of the LECHATLIER principle, how it is useful in this reaction, as well as when you do contact process. These would be important topics. Second is you should understand how ammonia is separated. Yeah, one thing that I missed was that ammonia is very soluble in water. You can dissolve 1 volume of ammonia in 700 parts of water. Is it making sense, Mr. CB?
Yes.
So basically, I think I have made a mistake here. It should be, I think it should be 700 volume of ammonia in one part of water. Yeah, then now it makes sense. This is a mistake. So this is basically what it means is you just take a liter of water, and you in that 1 liter of water you'll be able to dissolve 700 liters of ammonia. Mr. CB, is it making sense?
Yes.
So they will ask you how ammonia can be separated. It is separated by using 2 properties of ammonia. One is it liquefies early, then nitrogen and hydrogen. Second is it is highly soluble in water. Are we making sense or not?
Yes, sir.
So I have corrected this. It should be 1 volume water and 700 volume NH3. So Mr. Sibang, any doubt till here?
No.
So this extreme solubility, we will study this extreme solubility of ammonia as the fountain experiment also. Mr. Sibang, do you remember the fountain experiment?
Yes, sir.
So it will be used in the fountain experiment also, and it is very useful in separating ammonia out of a mixture of nitrogen, hydrogen and ammonia. I think this should be enough. The reaction is simple enough. It is the conditions and the reasons that you will have to remember. Any doubt till here?
No doubt.
So in the next lecture we'll understand the chemical properties of ammonia, and we'll also have a discussion on the fountain experiment. Yeah?
Yes.
Okay. And you'll have to have a look at the uses of ammonia also. I think it would be in your syllabus. Yeah? Okay.